Algebra. The term algebra is formed from the Arabic term Algebra, has gained popularity in 820 AD. Al-Khwarizmi, a Persian mathematician, wrote a book with the title Algebra wa al-Muqabla. The word algebra of the title has gradually changed to algebra. In 3rd century AD, a Greek mathematician called Diophantus was the first mathematician who used algebraic expressions in his book Arithmetica. Diophantus was known as father of algebra. Among Indian mathematicians, Aryabhatta of 5th century AD, Brahmagupta of 6th century AD, Bhaskaracharya of 12th century AD found many formulae and solutions to some algebraic equations. The concepts formed in the 16th century themselves helped a lot to develop modern algebra. Important terminology. Study of algebra is useful to solve day-to-day problems. For that, let us examine important terminology we use in this branch of mathematics with examples. Main examples. Example 1. Hearing the conclusions of Ramu and Somu, Jagan questioned that how many books are needed for X number of pupils. If 3 books are given freely to each student. For this, Ramu and Somu prepared a table similar to the previous one. Number of pupils attended 1. Number of books needed 3. Number of pupils attended 2. Books needed 6. Number of pupils attended 3. Number of books needed 9. Number of pupils attended 4. Number of books needed 12. Number of pupils attended 5. Number of books needed 15. Number of pupils attended 6. Number of books needed 18. On observing the table, Ramu and Somu said that at the rate of 3 books each, X pupils need 3 times the number of pupils. They understood that the formula is number of books needed is equal to 3 times the number of pupils. S is equal to 3x. S is equal to 3x. Another example. Not contented with that, Jagan questioned, what do you say about the number of pens if X pupils are given C pens each? Immediately Ramu and Somu said C times in chorus. That means if this is written in the form of formula, total number of pens needed S is equal to C times X. S is equal to C. X is equal to Cx. Constants, variables. The literal that can take any value from a given set of values is called a variable. The literal that has a constant value is called a constant. Generally, we represent the variables with lowercase English alphabets. If at all any literal is a constant, then it must be specifically indicated. In this case, we take the values of variables as well as constants from the set of rational numbers only. Fundamental operations of arithmetic with variables. Just like in arithmetic, we can do the 4 fundamental operations: addition, subtraction, multiplication and division with the variables in algebra also. Addition. Example. Ramaya, the cattle grazer, has 2 cows and his brother Lakshmaya has 3 cows. If the cost of each cow is rupees X, then what is the total cost of all the cows both of them have? Solution. Total number of cows is equal to number of cows of Ramaya plus number of cows of Lakshmaya is equal to 2 cows plus 3 cows is equal to 2 plus 3 cows is equal to 5 cows. Cost of each cow is rupees X. Cost of cows that Ramaya has in rupees is x plus x is equal to 2x. In this sum of 2x, s is shown as 2x. Cost of cows that Lakshmaya has in rupees is x plus x plus x is equal to 3x. Total cost of 5 cows in rupees is x plus x plus x plus x plus x is equal to 5x. Here, the sum of the cost of 2 cows of Ramaya and 3 cows of Lakshmaya equals the total cost of 5 cows. Therefore, can it be written as 2x plus 3x is equal to 5x? Think. 2x means x plus x. 3x means x plus x plus x. 5x means x plus x plus x plus till 5 times. Subtractions. Example. Gopi needs 5 notebooks and Shyam needs 2 notebooks. If each notebook costs rupees x, then how much money does Gopi need more than Shyam to purchase his needed number of books? Solution. Cost of 2 notebooks needed by Shyam in rupees is equal to x plus x is equal to 2x. Cost of 5 notebooks needed by Gopi in rupees is x plus x plus x plus x plus x is equal to 5x. Amount Gopi needed more than Shyam is equal to amount needed by Gopi minus amount needed by Shyam. Rupees 5x minus 2x is equal to rupees 5 minus 2 into x is equal to rupees 3x. Multiplication. Example. The money with Raju is 3 times the money that is with Ravi. If Ravi has rupees x, how much money is with Raju? Solution. Money Ravi has is rupees x. Money Raju has is 3 times the money Ravi has with him is equal to 3 into rupees x is equal to rupees 3 into x is equal to 3x. Division. Example. If rupees 100 is distributed equally among 5 persons, how much will each get? Solution. Money each one gets is equal to rupees 100 divided by 5 is equal to rupees 100 by 5 is equal to rupees 20. Power index. Let us observe the context where a number or a literal is multiplied by itself several times. In such situations, let us acquaint ourselves with the terminology used in such situations. We represent the process of multiplying 3 by 3 as 3 into 3, isn't it? We write the same as 3 square also. This is called exponential form. Because of the reason that we use 3 2 times to represent the product 3 into 3, it can be written as 3 square. Similarly, we write 3 into 3 into 3 into 3 as 3 to the power of 4. That means we use 3 4 times in this product. The number of times we multiply a quantity is called index or exponent. In 3 to the power of 4, 4 is called index or exponent and 3 as base. Example. Let us observe bases and exponents in the following exponential form. 1. In 5 to the power of 6, base is 5, index or exponent is 6. 2. In 6 to the power of m, base is 6 and exponent is m. 3. In a to the power of k, base is equal to a and exponent is equal to k. Example 6. If 3 by 4 into a square into b square is written in product form, it becomes 3 by 4 into a into a into b into b. This is read as 3 by 4 a to the power of 2 b to the power of 2. 1. The product form of 7 by 5 b cube c to the power of 4 is equal to 7 by 5 into b into b into b into c into c into c into c. 2. The product form of 5 by 9 k to the power of 5 l to the power of 7 is equal to 5 by 9 into k into k into k into k into k into L into L into L into L into L into L. 3. The product form of 11 by 15 a to the power of 3 b to the power of 6 is equal to 11 by 15 into a into a into a b into b into b into b into b. 5. The product form of 2 by 3 m to the power of 2 n to the power of 3 is equal to 2 by 3 into m into m into n into n into n. Example: m by n to the power of 5 means m by n into m by n into m by n into m by n into m by n. The exponent is for whole value of m by n. This is read as m by n whole power of 5 or m over n whole raised to the power of 5. 1. K by L whole power 3 is equal to K by L into K by L into K by L 3 times. 2. P by Q whole power 4 is equal to P by Q, P by Q, P by Q, P by Q 4 times. 3. 3 by X whole power 5 is equal to 3 by X, 3 by X, 3 by X, 3 by X, 3 by X 5 times. M by 5 whole power 6 is equal to M by 5 6 times. Algebraic expression. A constant or a variable or the product of a constant and a variable is called a term. 4, 7 by 5, x, p, minus tx, 4 by 3 x square, 3xy, minus abc, minus 7 into 8. In the above example, the first two terms and the last term are called constant terms and the rest are called literal terms. The expression containing at least one algebraic term is called an algebraic expression. Numerical expression and algebraic expression. Example: 7 plus 5, 8 minus 3, 24 into 7, 8 plus 10 minus 11, 22 by 7, etc. Monomial. Expression containing only one term is called a monomial. Example: 7x minus 5 by 6ab minus xyz. Binomial. The expression containing two terms is called a binomial. Example: 7x plus 5 minus 4 by 3a minus b x square minus y abc plus 2 by 3x. In 7x plus 5, 7x and 5 are two terms. In minus 4 by 3a minus b, minus 4 by 3a and minus b are two terms. In abc plus 2 by 3x, abc and 2 by 3x are two terms. All these are binomials. Trinomial. The expression containing three terms is called a trinomial. Example: 3x minus 3y plus 7 by 2z abc plus p plus 4 by 3. In 1 by 2 plus m by 3 minus n cube by 7. In 3x minus 3y plus 7 by 2z, 3x minus 3y and 7 by 2 are three terms. In abc plus p plus 4 by 3, abc, p and 4 by 3 are three terms. In 1 by 2 plus m by 3 minus n cube by 7 or 3 terms. So these are trinomials. Coefficient. In a product of two or more factors, every factor is called the coefficient of the product of the remaining factors. If the coefficient is a number, then it is called numerical coefficient. And if it is literal term, then it is called as literal coefficient. If the numerical coefficient is 1 or -1, these will not be given. 1a is written as a and -1a is written as -a. Generally, numerical coefficient is used as coefficient of that term. Like and unlike terms. Terms having same literal coefficients are called like terms, while terms having different literal coefficients are called unlike terms. Example, 3xy minus 4xy are having same literal coefficients x, y and xy. So these are like terms. Degree of literal terms. The sum of all the exponents of the literals is called the degree of literal term. Example, the degree of minus 4 by 3 x square y z to the power of cube is equal to exponent of x plus exponent of y plus exponent of z is equal to 2 plus 1 plus 3 is equal to 6. Value of an algebraic expression. We get the value of the algebraic expression by substituting the given values for the variables in the given expression. Process of solving. Steps. 1. The given expression should be written. The values of the variables are to be substituted. 3. Simplification is to be done. Example, if x is equal to 4, then what is the value of 2x plus 5? Method of solving. Solution. 1. The given expression is written 2x plus 5. 2. We substitute 4 for x in the given expression, 2x plus 5. 2 into 4 plus 5. Simplify is equal to 8 plus 5 is equal to 13. Therefore, if x is equal to 4, then 2x plus 5 is equal to 13. Algebraic expressions. Addition. The sum of algebraic expressions can be obtained by adding or simplifying the like terms of the given expressions. Let us see the method of adding like terms. Adding like terms. In the process of adding like terms, first we should add and simplify their coefficients. Example, simplify 7x minus 5x plus 8x plus minus 6x plus 16x. Solution, 7x minus 5x plus 8x plus minus 6x plus 16x. Write it as 7 plus minus 5 plus 8 plus minus 6 plus 16 x is equal to 31 plus minus 11 x is equal to 20x. Horizontal method. The way of approach in this method. 1. All the expressions ought to be written with addition symbol in between them. 2. The like terms ought to be grouped. 3. The numerical coefficients ought to be simplified. 4. The expression is to be written with the simplified coefficients. Add the expressions. 3x minus 6y plus 4. 3y minus 2z minus 6x. 4z minus 3y plus 6x minus 5. Solution. Sum of the given expressions is equal to 3x minus 6y plus 4 plus 3y minus 2z minus 6x plus 4z minus 3y plus 6x minus 5 is equal to 3x minus 6x plus 6x plus minus 6y plus 3y minus 3y plus minus 2z plus 4z plus 4 minus 5 is equal to 3 minus 6 plus 6 into x plus minus 6 plus 3 minus 3 into y plus minus 2 plus 4 into z plus minus 1 is equal to 3x minus 6y plus 2z minus 1. Addition column method. Process to be followed while adding the expressions in column method. 1. All the expressions are to be written one below the other such that all the like terms occur in the same column. 2. If an expression does not contain any like term of the previous one, space is to be left under that. 3. The sum obtained by adding all the like terms of the column is to be written just below that column. Example. Add the expressions 3x squared minus 4xy plus 4y squared, 3xy plus 4y squared minus 3x, 14y squared plus y. Now add 3x squared minus xy plus 22y squared minus 3x plus y. Algebraic expressions, subtraction. Before we proceed to subtraction of algebraic expressions, let us examine the concept of additive inverse. Additive inverse. The additive inverse of a term is nothing but the same term with altered prefix sign. Write the additive inverses of 5x minus 7xy and 8y squared. Solution. Additive inverses of 5x is equal to minus 5x. Additive inverses of minus 7xy is equal to 7xy. Additive inverses of 8y squared is equal to minus 8y squared. Algebraic expression additive inverse. The additive inverse of an algebraic expression is the expression containing the sum of all the additive inverses of each and every term of the given expression. Example. Write the additive inverse of the expression 3x squared minus 4xy plus y squared plus 5. Solution. The additive inverse of 3x squared minus 4xy plus y squared plus 5 is equal to minus 3x squared plus 4xy plus minus y squared plus minus 5 is equal to minus 3x squared plus 4xy minus y squared minus 5. Subtraction of algebraic expressions. In order to subtract an algebraic expression from another algebraic expression, the additive inverse of the former expression is to be found first, and then this expression is to be added to the later expression. Example. Subtract 3x squared minus 5x minus 4 from 5x squared plus 6x plus 8. The additive inverse of 3x squared minus 5x minus 4 is to be added to 5x squared plus 6x plus 8. The additive inverse of 3x squared minus 5x minus 4 is equal to minus 3x squared plus 5x plus 4 is equal to minus 3x squared plus 5x plus 4. That means minus 3x squared plus 5x plus 4 is to be added to 5x squared plus 6x plus 8. We know addition of two algebraic expressions, isn't it? 5x squared plus 6x plus 10 plus minus 3x squared plus 5x plus 4 is equal to 5 plus minus 3x squared plus 6 plus 5x squared plus 8 plus 4 is equal to 2x squared plus 11x plus 12. Similar to the addition, we do the subtraction in two methods. Those are 1. Horizontal method, 2. Column method. Subtraction of algebraic expressions. Horizontal method. Process of finding solution in this method. 1. The expression from each another expression is to be subtracted must be written in brackets first. Later, after writing the negative sign, the expression to be subtracted must be written in brackets. 2. After changing the negative sign in between the brackets into positive sign, the additive inverse of the expression must be written in the second bracket. The like terms in these two brackets must be grouped. Next, add the coefficients of the like terms. 5. Simplify. Subtract 3a squared minus 4ab from 7a squared minus b squared plus ab. Solution: 7a squared minus b squared plus ab minus 3a squared minus 4ab is equal to 7a squared plus b squared plus ab plus minus 3a squared minus 4ab is equal to 7a squared plus 3a squared plus minus b squared plus ab plus 4ab is equal to 7 minus 3 into a squared plus minus 1 b squared plus 1 minus 4 ab. 4a squared plus b squared plus 5ab. Subtraction of algebraic expressions. Column method. Process of solving. 1. The expression from which another one is to be subtracted must be written first. 2. The expression to be subtracted must be written below the first one so that the like terms come in the same column. 3. The signs before the terms of the second expression must be changed. Considering the signs of the second expression, every term of it must be added to the term just above it. 5. The resulting term obtained by adding the columns must be written under those columns only. Example: subtract 2x squared plus xy minus 3 from 3x squared plus 3y squared plus 4. 3x squared minus 5xy plus 3y squared plus 4 minus 2x squared plus xy minus 3. Answer: x squared minus 6xy plus 6y squared plus 7. Algebraic expressions. Multiplication. First, let us see how an expression is multiplied with a constant. Example: 5 into 2x minus 5y plus 2 by 3 x cube. Solution: the constant is multiplied with every term of the expression and then the resulting terms are to be added. 5x into 2x minus 5y plus 2 by 3 x cube is equal to 5 into 2x plus 5 into minus 5y plus 5 into 2 by 3 x cube is equal to 10x minus 25y plus 10 by 3 x cube. Product of two monomials. Now let us examine the product of two monomials. The process of finding the product of two monomials is as follows. 1. First, we should write the product of two numerical coefficients of the two monomials. In the same manner, the product of the literal coefficients must be written. 3. The resultant product of the numerical and literal products must be written. Example: what is the product of 2 by 3 xy squared and minus 4x cubed y? Solution: the product of 2 by 3 xy squared and minus 4x cubed y is equal to 2 by 3 xy squared into minus 4x cubed y is equal to 2 by 3 into minus 4 into xy squared into x cubed y is equal to minus 8 by 3 x into x cube into y square into y is equal to minus 8 by 3 x to the power of 4 y to the power of 3. Product of two or more monomials. The process of finding the product of two or more monomials is as follows. 1. The numerical coefficients of the two monomials are to be multiplied. 2. The product of all the literal coefficients must be found. 3. The product of the above two is the required result. Example, simplify minus 7a square b into 4bc cube into 5 by 7 a square bc into 21a. Solution, minus 7a square b into 4b cube into 5 by 7 a square bc into 21a is equal to minus 7 into 4 into 5 by 7 into 21 a square b into bc cube into a square bc into a is equal to minus 420 into a square into a square into a into b into b into b into c cube into c is equal to minus 420 a to the power of 5, b to the power of 3, c to the power of 4. Multiplying a binomial with a monomial. The binomial is said to be multiplied by a monomial when all the terms of binomial are multiplied by the monomial and the resulting terms are summed up. It also has two methods. Those are A. Horizontal method, B. Column method. A. Horizontal method. Let us examine how a binomial is multiplied with a monomial in horizontal method. Example, multiply y plus 3 by 4 z with 3x. Solution, y plus 3 by 4 z into 3x is equal to y into 3x plus 3 by 4 z into 3x is equal to 3xy plus 9 by 4 zx. Column method. Let us observe how a binomial is multiplied with a monomial in column method. Example, what is the product of 2 by 3 xy and 6x minus 9y? Solution, 6x minus 9y into 2 by 3 xy. 6 into 2 by 3 x square into y minus 9 into 2 by 3 xy squared. On simplification, we get 4x squared y minus 6xy squared. Brackets. In order to show the order of operations to be performed in mathematics, we use brackets. Let us know about them. Kinds of brackets. We use 4 kinds of brackets in mathematics. They are 1. Vinculum or bar bracket. 2. Small bracket or parenthesis. 3. Curly bracket or flower bracket. 4. Square bracket. Method of usage and removal of brackets. We use small brackets very frequently. We use this small bracket when only one bracket is needed. The vinculum or bar bracket is used rarely. That is to say, when all the 4 brackets are needed. The 4 brackets are to be used or removed in the order given here under. First, bar bracket. Next, second bracket, parenthesis. Next, third bracket, curly bracket or flower bracket. And finally, fourth bracket. Square bracket must be used or removed in this order. Uses of brackets. Write the following expression using brackets. 1. Subtract z from y. Subtract this result from x and then add the resultant to 9. 2. Subtract the sum of b and c from a and then add 2. Multiply this result with b and subtract, so obtain result from A and then add 1. Solution 1. Result after subtracting Z from Y is equal to Y minus Z. Subtracting this result from X. X minus Y minus Z. On adding 9 to it, curly bracket open, X minus bracket open, Y minus Z, closing the bracket, closing the curly bracket, plus 9. 2. Sum of B and C is equal to B plus C. On subtracting this result from A is A minus B plus C. And this B plus C in the bar bracket. On adding 2 to this, A minus B plus C plus 2. On the multiplying this result with B, we get B into A minus B plus C plus 2. The result on subtracting this result from A is A minus B into A minus B plus C plus 2. Adding 1 to this, we get open square bracket A minus B, curly bracket open, A minus B plus C, close the small bracket, plus 2, close the curly bracket, and close the square bracket, plus 1. Method of removal of brackets. The method of simplification after removal of the brackets in arithmetic will be used with algebraic expressions also. Equations. Previously, we discussed about numerical expressions and algebraic expressions. We know that numerical expressions have the relations like equal to, greater than, less than, not equal to, not less than, not greater than, etc. Numerical sentence statement. The sentence formed by any two numerical expressions with any sign of relation shown above is called a numerical sentence. The sentence which is either true or false is called a statement. Mathematical sentence. The sentence formed by an algebraic expression and a numerical expression are two algebraic expressions with one of the relations is equal to, greater than, less than, not equal to, not less than, not greater than is called mathematical sentence. Example 1. 7x plus 4 is equal to 1. M cube greater than 64 minus n. X plus y greater than 100 plus z. X square not equal to 0. Equation. The open sentence with equality relation is equal to is called an equation. Example. In the equation x plus 5 is equal to 10, LHS is equal to x plus 5 and RHS is equal to 10. Solution or root or truth value of an equation. For what value the given equation becomes a true statement, that value is called the solution or root or truth value of that equation. Example. In the equation x plus 5 is equal to 10. When x is equal to 1, 1 plus 5 is equal to 10 is false. When x is equal to 2, 2 plus 5 is equal to 10 is false. When x is equal to 3, 3 plus 5 is equal to 10 is false. When x is equal to 4, 4 plus 5 is equal to 10 is false. When x is equal to 5, 5 plus 5 is 10 is true. When x is equal to 6, 6 plus 5 is equal to 10 is false. In the above example, for the values 1, 2, 3, 4 and 6 of x, the equation is false. Whereas for 5, the equation is true. That means the solution or root or truth value is 5. Kinds of equation. 1. M plus n is equal to 25. 2. X square is equal to 100. 3. X square minus x is equal to 7. 4. A plus B plus C is equal to 10. 5. X plus 10 is equal to 25. 6. P minus 5 is equal to 6. If you examine the above equations, 2 points will be clear. They are: 1. There may be more than one variable in an equation. In the above examples, numbering 2, 3, and 5, x is a variable. In 6, p is a variable. In 1, m and n are the 2 variables, and in 4, a, b, c are the 3 variables. 2. The largest exponent of a variable may be more than 1. In the above examples, numbering 1, 4, 5, and 6, the largest exponent is 1, in 2 it is 2, and in 3 it is 3. Solving simple equation, trial and error method. Solve the equation 3x plus 4 is equal to 10. Solution. Let us examine the value of LHS and RHS by substituting values for the variable x. Substituting value 1, value of LHS 3x plus 4, value of RHS 10. Substituting value 1 on LHS, 3 into 1 plus 4 equal to 7, value of RHS 10. Substituting value 2, value of LHS 3 into 2 plus 4 is equal to 10, value of RHS 10. Substituting value 3, 3 into 3 plus 4 is equal to 13 on LHS, whereas 10 on RHS. Substituting value 4, 3 into 4 plus 4 is equal to 16 on LHS, whereas 10 on RHS. From the above table, it is understood that the values of LHS and RHS have become equal when 2 is substituted for x. Therefore, its solution is x is equal to 2. The way we follow in the above is called trial and error method. The method through which the solution of a given equation is found by substituting different values for the variable is called trial and error method. Domain of variable. The set of substituting values for the variable of the given equation is called domain of the variable. Example: solve the equation x plus 3 into x plus 1 is equal to 11 if the domain of the variable is 1, 2, 3, etc. Solution. Value of the variable for substitution 1. On LHS, 1 plus 3 into 1 plus 1 is equal to 7. On RHS, 11. Value of variable 2. On LHS, 2 plus 3 into 2 plus 1 is equal to 11. On RHS, 11. Value of variable 3. 3 plus 3 into 3 plus 1 is equal to 15. On RHS, 11. From the above table, we infer that the values of LHS and RHS of the equation are equal when x is equal to 2. So, its solution is x is equal to 2. Solution of general equation, algebraic method. Solving process. The equation is to be reconstructed using logical methods so that all the variable terms are on one side and the constant terms on the other side of equal to. 2. Again adopt algebraic process so that the coefficient of variable reduces to 1. 3. Simplify for the value of the variable.